Okay, so then we had some students ask about 43, but I want you guys to do 43 in your homework, so I'm going to do one like number 43, another example. Again, I don't like to have two radicals on one side, so I'm going to move that over. So I'm going to have radical 4x plus 1 is equal to, and it doesn't matter if you have your radical first or your number first. So I'll work this one differently to show you what it looks like. Now square both sides, and you get 4x plus 1 is equal to, and just think square double square. I'm using the pattern a plus b squared is equal to the first thing squared plus 2 times the things multiplied together plus the last thing squared. Like, this is a wonderful formula to use. Okay? So first thing squared is 2x plus 4. 1 times that times 2. 2ab is 2 times that. In our classroom, you know, we say square double square. So we square it, then we're going to double it. So that's going to be 2 times radical 2x plus 4. And then we square the last thing, plus 1. And you would have got the same thing. I just used this pattern. You'd get the same thing if you wrote it all out and did it the long way. That would be perfectly fine. Okay, so now I want to combine like terms. So I've got 4x plus 1 on this side, 2x plus 5 plus 2 radical 2x plus 4. So when I bring 2x over, I'm left with 2x. When I bring the 5 over, I've got minus 4 is equal to 2 square root 2x plus 4. So I almost have my radical alone. I've got a 2 on it. Do I want to divide everything by 2? Yes, because over here, that would just, they're both divisible by 2, so I can do that. So this gives me x minus 2 is equal to radical 2x plus 4. Now, in the last problem that we did, we didn't have a letter. Remember the x's canceled out? And so we just had a number. It was like 3. And so 3 times 3 was 9. That's easy. Well, I got an x minus 2. So you've got to square, when you square both sides, you've got to square that quantity. And it's not x squared plus 4 or x squared minus 4. It's square double square. You're going to use this formula again. So that's x squared minus 4x plus 4. And this side is 2x plus 4. And again, on the last example, because we had a 3 and we squared it and we got 9, we didn't have a quadratic to solve. We now have a quadratic because I got an x squared, so I got to set it equal to 0. The 4's are going to cancel when I subtract 4 from both sides. And when I bring that over, I get x squared minus 6x equals 0. When you have a quadratic that does not have a constant, all you need to do is factor it. Yep, factor out an x and an x minus 6. And so your answers are x equals 0. Whenever you have an x out in front, that gives you x equals 0, and then x equals 6. Then always double check. We should have double checked on the last example. Double check and plug those numbers in and see if they work. So if you go back up to the top, if you plug in 0, that gives you 1 minus 2. Is 1 minus 2 equal to 1? Is 1 minus 2 equal to 1?
No, it's negative 1.
You're correct. So we cannot use x equals 0. So you cross off x equals 0. And you take a 6, 24 plus 1 would make that thing be 5. So 5 minus 16, 4. So 5 minus 4. Is 5 minus 4 equal to 1?
Yeah.
Yes, so we use the 6. Because square roots are plus and minus, a lot of times that'll happen. Like when you plugged in 0, we would have got negative 1 on this side. And we plugged in 6, we got a positive 1 on this side. That's why, especially when you get 2, you need to check them. Okay? All right.